class. Today we are going to see a major and a most important topic in metallurgy, which is iron carbon phase diagram. So most of the or all the foundries which is dealing with ferrous based alloys will run under this iron carbon phase diagram. Okay. So this iron carbon phase diagram looks like this. Okay. So we'll call this iron carbon diagram as iron carbon diagram or Fe₃C diagram or iron cementite diagram. Okay. So these are the names for this particular diagram. Okay. So based on this diagram only, we are creating a number of grades of metals starting from mild steel, stainless steel, etc. So when we come to this ferrous carbon classification, so here you can see ferrous and carbon. So ferrous is the major alloy or a major element, and the carbon is the additional alloy which is mixed with ferrous to form this steel. Okay. So from there we are taking we are creating n number of grades of steel. Starting from here, mild steel, we have more than 10 number of grades. Stainless steel, tool steel. Tool steel is supposed to be have 20-25 grades of steel. Thus, the grades are depend upon the ingredients what we are adding. Means what are the alloy elements you are adding? It is based upon the alloy addition. The name of the steel will get increases. If you are for a particular steel, if a steel is there, if you are mixing with iron and ferrous and carbon, you get steel. If you add chromium and nitrous, chromium and nickel to a particular percentage to a steel, the normal steel will become stainless steel. Okay, so we'll go inside, right?
So these are the major phases. While coming to this diagram, can differentiate as the 5 individual phases as well as the major phases. Here we can see the temperature as well as the weight percentage of the carbon, how it works on. Likewise, Fe₃C plays a major role here. So based upon the temperature, uh, the way also the weight percentage of the carbon, the graph moves upon the thing like acetane, ferrite, perlite, delta ion as well. So from here the carbon percentage will be defined as something. The major 5 individual phases are alpha ferrite, which is a combination of iron as well as carbon as a solid solution. Then austentane, same as the iron as well as carbon solid solution. So these were the at last we have seen the liquid iron carbon solution.
So here it is the atomic radius. So the particular slide what I have given is that see there is a Hume-Rothery rule to form a solid solution. So means that the carbon will be seen like this. Okay, it is forming the interstitial. Means that in between two iron atoms, a carbon atom will be fixed so that we can form a solid solution easy. Right.
Seeing upon the invariant reactions, the austenity has come upon the degrees of 1492 degrees Celsius from delta N with a carbon percentage of 10%, and it transfers to liquid. When it is cooled down, it becomes austenity. When the process is reversed, it comes to liquid stage and delta N.
See here is there are delta N or see delta N plus liquid upon cooling will get arsenate. Upon heating, the vice versa will take place. Okay, likewise, the next is eutectic reaction.
The as coming to the invariant reactions in iron carbon diagram, we have three invariant reactions. One is as I said pre-tectic, and then another one is eutectic, and the third one is eutectic. Now we are going to see about the eutectic reactions. The eutectic reaction happens in a temperature of 1130 degrees Celsius, and here we have a liquid which is 4.3 percentage of carbon considered, and then while cooling it we get austenite and then cementite, which the austenite has carbon percentage of 2 percentage, and the cementite has carbon percentage of 6.67 percentages. As we combine these both and call it as liberate and eutectite mixture. It's a mixture of austenite and cementite. So these are the diagrams. While cooling, we get an austenite and cementite combination, liberate. And then while heating the liberate, we get a liquid which consists of 4.3 percentage of carbon.
So coming to the eutectoid reaction, here we cool down the austenite to get ferrite and cementite. The austenite contains 0.8% of carbon, and like while cooling we get the ferrite of 0.25% of carbon and cementite of 6.67% of carbon. Like if we are heating the ferrite and the cementite, we get austenite, and the same like if we cool the austenite, we get the ferrite and cementite. The process, the ferrite and cementite is combined together. We call it as perlite, which is in the ectoid reaction.
So as you all say, this is the combined form. As Aryan say, yeah, invariant. Say individual phases. The reactions what you say. So combining will get the iron carbon alloy phase diagram. Okay. So here we'll see a single phases individually. Okay.